You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Virtual private clouds are the foundational units of cloud networking, providing logically isolated environments for deploying workloads, services, and infrastructure components. VPCs allow organizations to replicate the behavior of traditional networks complete with routing, subnets, and firewall policies inside public cloud platforms. Each VPC is a private space within the shared cloud infrastructure, enabling cloud users to define their own IP address ranges, security policies, and internet connectivity. For the Cloud Plus certification, understanding how VPCs are designed and interconnected is key to building scalable and secure networks. Two of the most important architectural patterns in VPC design are hub and spoke and VPC peering. These models enable communication across multiple networks, departments, or projects, each with different goals for isolation, control, and access. Cloud platforms support both models natively, and the design choice depends on how centralized the network management needs to be. The Cloud Plus exam tests your ability to identify which topology is appropriate, understand the routing and security implications, and plan accordingly for both scalability and operational efficiency. A virtual private cloud is a software-defined network space where users control all aspects of traffic flow and resource access. It includes components such as subnets for segmenting the network, route tables for defining traffic paths, gateways for connecting to external networks, and firewalls or security groups for enforcing access rules. VPCs are tenant-specific, meaning each user or account operates within their own isolated network. This design supports compliance, multi-tenancy, and workload isolation in the cloud. Hub and spoke architectures centralize control by placing shared resources in a hub VPC and connecting multiple spoke VPCs to it. The spoke networks do not connect directly to each other, but rather route traffic through the hub. This design simplifies the enforcement of security policies and makes it easier to deploy shared services such as domain name systems, directory services, or network address translation. Hub and spoke architectures are favored in large organizations where different departments or teams require access to a common set of infrastructure services. The use cases for hub and spoke models vary, but they often include connecting multiple development environments to shared production services or allowing business units to access centralized monitoring and logging tools. With all traffic funneled through the hub, network management becomes more consistent and policy changes can be implemented in a single location. This centralized approach also supports more effective auditing and network visibility, both of which are critical for operational security. In a hub and spoke model, routing and firewalling are typically handled at the hub. Each spoke VPC defines routes that send relevant traffic to the hub, and the hub handles the distribution or inspection of that traffic. Firewalls and access control lists are also concentrated in the hub to prevent lateral movement between spokes. This segmentation approach supports zero-trust architecture and helps satisfy compliance requirements that restrict internal communication between projects or business units. VPC peering is a more decentralized alternative that allows two VPCs to communicate directly without routing traffic through the public internet. Peering links are private and low latency, and they support resource sharing across accounts, cloud projects, or even organizational boundaries. In a peering relationship, each VPC retains control over its own address space and policies, but traffic can flow between them if routes and security rules are configured properly. Cloud Plus candidates must understand how to implement peering connections and what configurations are required to make them effective. Peering relationships can be either unidirectional or bidirectional. A unidirectional configuration allows traffic in one direction only, while bidirectional setups permit communication in both directions. Each side must define routes that point to the peering connection and update its security groups or firewall rules to permit traffic. Even if the peering link is technically active, misconfigured routes or rules can prevent connectivity. These configuration details are often the focus of troubleshooting questions on the exam. Some cloud providers support cross-region VPC peering, which enables organizations to connect workloads across geographic boundaries. This is useful for global applications, disaster recovery designs, and compliance with regional redundancy requirements. Cross-region peering introduces additional latency and may incur higher costs compared to local peering. Planning these designs requires attention to route propagation settings, IP address planning, and cost control strategies. The exam may test knowledge of regional versus global peering behavior and design implications. There are limitations to VPC peering that influence its suitability for large-scale environments. Peered VPCs cannot transit traffic to a third VPC, meaning traffic must be routed point-to-point. Also, overlapping IP address ranges are not allowed, which requires careful coordination during network planning. As the number of VPCs grows, managing many individual peering links becomes complex. In such cases, transit gateways or software-defined networking solutions provide more scalable alternatives. Candidates must recognize when peering is sufficient and when to transition to more advanced routing models. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Monitoring and managing peered networks is critical for maintaining visibility and security. Cloud providers offer logging tools and metrics that allow administrators to observe traffic patterns, connection status, and anomalies in peered environments. These logs help verify that only permitted traffic is flowing between VPCs and that no unauthorized access has occurred. Through the Cloud Console or application programming interfaces, administrators can audit peering links, confirm route table accuracy, and ensure that firewall rules are aligned with traffic expectations. For the Cloud Plus exam, candidates should be able to explain how these monitoring tools support operational integrity. VPC peering often involves the sharing of central services such as load balancers or internet gateways. In hub-and-spoke configurations, the hub VPC may host a centralized load balancer that serves traffic from multiple spokes. Similarly, virtual private network gateways or direct connect interfaces may reside in the hub to provide unified ingress and egress control. When designing shared resource models, routing tables and security policies must be carefully configured to ensure that traffic reaches its destination while remaining secure and isolated from unrelated tenants. Inter-VPC connectivity introduces potential costs, especially when data moves across regions or between billing entities. Some cloud platforms charge for data transferred over peering links, particularly for cross-region communication. Designers must be aware of these cost models to avoid surprise charges and to ensure efficiency. Aggregating traffic through the hub and minimizing cross-region transfers can reduce expenses. The Cloud Plus exam may present questions that require choosing a topology that balances performance, cost, and resource visibility. High availability is another consideration in VPC design. Each VPC should span multiple availability zones where possible, ensuring that workloads remain accessible even if one zone becomes unavailable. In hub-and-spoke or peering models, routes should be designed to support automatic failover, and redundant paths should be established between critical VPCs. Some cloud providers support route health injection or dynamic route advertisements to trigger failover behavior. Candidates must understand how to plan for failure and ensure that inter-VPC traffic continues to flow during outages. Policy enforcement across VPC boundaries is central to securing multi-network designs. Identity-based policies, often implemented through tags, role-based access control, or directory integration, allow administrators to define who can access what across connected VPCs. Firewalls and security groups reinforce these policies by filtering traffic at the network level. By using consistent naming conventions and centralized policy definitions, Teams can apply rules at scale without duplicating configuration effort. The exam may include questions that require enforcing access controls across multiple VPCs with varying levels of trust. Centralized DNS and directory services are commonly deployed in the hub of a hub-and-spoke network. By locating these services in one place, organizations reduce administrative overhead and improve resolution consistency. Spoke VPCs can query the centralized DNS to resolve names across the environment, and directory services can authenticate users and systems across tenants. However, proper forwarding rules and security configurations must be implemented to support cross-VPC queries. The Cloud Plus exam may present diagrams showing incomplete DNS integration or authentication issues between peers. As environments scale, maintaining direct peering links between all VPCs becomes inefficient. Transitioning to a transit gateway or similar software-defined networking fabric allows for centralized management of many-to-many traffic flows. Transit gateways act as routing hubs, eliminating the need for individual peerings between every VPC. This change simplifies administration, supports route propagation, and improves observability. Migrating to this architecture may require temporary routing overlaps and policy harmonization. Candidates must know when and how to move from peering to more scalable solutions. The Cloud Plus exam often includes visual questions where candidates must identify VPC topologies, troubleshoot traffic flow issues, or recommend architecture changes. These scenarios may include broken route tables, missing peering relationships, or improper firewall settings. A strong grasp of VPC behavior, including routing rules, security boundaries, and design limitations, is essential for success. Mastery of topology patterns and their use cases also supports practical tasks like integrating acquisitions, extending hybrid networks, or segmenting development and production. Best practices in VPC design always center around planning for growth, security, and manageability. Hub-and-spoke models support centralized control, making them ideal for environments with shared services or compliance requirements. Peering is lightweight and useful for tightly coupled environments with low administrative overhead. Regardless of the model, clear IP planning, route documentation, and layered security controls are essential. The Cloud Plus exam emphasizes these practices as part of cloud networking fundamentals, expecting candidates to select, deploy, and maintain robust virtual networking topologies. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.